What we need to do now, lads, is that we need to do the 7th theorem on the junior cert course, okay? Now what the 7th theorem is basically is that it involves what's called a tangent. Now a tangent basically, lads, has got 3 characteristics. Number 1, a tangent, as we see from the diagram, is a straight line, okay? Number 2, a tangent is a line which touches a circle at only one point. It doesn't cut through the circle, it touches the circle at only one point. And the third characteristic is that if you draw a line from the point of contact between the tangent and the circle to its centre, then those lines will be perpendicular. Okay? Now that's crucial, lads, when we're evaluating and we're looking at tangents. Number 1, it's a straight line. Number 2, it's only got one point of contact. And number 3, the diameter of the circle is perpendicular to the tangent at the point of contact. Now what Theorem 7 asks us to do, it's basically that if we have a line that touches the circle at only one point, and if the tangent, or sorry, if that line is perpendicular to the diameter, we want to prove that if those two things are correct, then that line is a tangent to the circle at the point. Okay? Now, can we just look at what we are given first of all? What are we given? We are given in the diagram, lads, a line L. We're given point B, that's an element of L, and lies on the circle. Okay? And we're given the diameter BF, with centre of circle point W. Okay? So that's what we're initially given. What are we asked to prove? We're asked to prove, lads, that the line is a tangent to the circle at that point. Okay? We want to prove basically that point B is the only point at which that line touches the circle. If we can do that, then therefore it must be a tangent. What is our construction? Our construction here, lads, basically is that we pick any point on the tangent, on the line L. We pick any point on the line L, in this case point C, right? So you let point C be any point on the line L, and basically then you join point C to point W. Okay? Now, what if we look then, lads, at the triangle CBW, what can we say about that triangle? We can say about the triangle CBW that it's a right angle triangle. Therefore, CW is the hypotenuse of the triangle. Right? What do we know about the hypotenuse of a triangle? What we know about it is that it's always going to be the longest side of the triangle. And that's what comes into the proof very much. Okay? So any point on L, point C, join C to W, and then that gives us a right angle triangle. When we have the right angle triangle, we have a hypotenuse CW, which, as we know, is the longest side of the triangle. Now if we look at the proof, lads, there please, okay? Our proof is, if we look at the triangle CBW, as we said, CW is the hypotenuse, which is the longest side. Therefore, CW is longer in length than BW. So CW is longer than the radius of the circle. Therefore, C must lie outside the circle. Because CW is longer than BW, which is the radius, C must lie outside the circle. And then you say a very general statement, which is, similarly, all other points except B lie outside the circle. Therefore, it touches the circle at only one point, line L touches it at only point B, therefore it must be a tangent to the circle. Okay? Now it's quite long, lads, but if you follow it step by step in that way, it should prove okay. Any questions, please? Okay, thank you.